Try and solve the integral of the square root of negative x squared plus 6x minus 8. There are 35 days left of this math countdown, so make sure you stick around to see what I'm counting down until. So the first step to solve this integral is to complete the square of the trinomial inside the square root. So taking out a negative, we have negative into x squared minus 6x plus 8. Then, when we complete the square, we have x squared minus 6x, and then this is plus 3 squared minus 3 squared plus 8. So that simplifies to negative x squared minus 6x plus 9, which can be written as a square when you factor it as x minus 3 all squared, and then we have this negative 3 squared plus 8. Negative 3 squared is negative 9, negative 9 plus 8 is negative 1. Now we distribute this negative back and we get 1 minus x minus 3 squared. So putting that back under the square root, we have the integral of the square root of 1 minus x minus 3 squared. So we can now make a trig substitution. So we're going to let x minus 3 equal to sine of theta. And the reason why we're doing this is because 1 minus sine squared of theta is cosine squared of theta. And cosine squared of theta square rooted is just cosine of theta. So this will dramatically simplify our integral by substituting in x minus 3. And I'll show you exactly what I mean. So deriving this expression of x in terms of theta, we get the derivative of x is equal to, now the derivative of negative 3 in terms of theta is just 0. The derivative of sine of theta in terms of theta is cosine of theta. Okay, so now substituting these into our integral, we get the integral of the square root of 1 minus sine squared of theta, because for x minus 3 I'm substituting in sine of theta, and then for dx I'm substituting in cosine of theta d theta. Okay, but we know that 1 minus sine squared of theta is equal to cosine squared of theta. And the square root of a square is just what was inside originally, so it's cosine of theta now times by cosine of theta. So this now is cosine squared of theta. So simply by substituting in sine of theta for x minus 3, and then doing the same for dx when we derived x in terms of theta, we simplify this integral in terms of theta to be the integral of cosine squared of theta. Okay, now we know from cosine, the identity that says that cosine of 2 theta is equal to 2 cosine squared of theta minus 1. We know that if we remanipulate this, we can isolate cosine squared of theta being equal to cosine of 2 theta plus 1 all over 2, or cosine of 2 theta over 2 plus 1 over 2. So we can substitute these two terms in for cosine squared of theta, and we get the integral of cosine of 2 theta over 2 plus 1 over 2 d theta. Okay, so solving this integral, the integral of cosine is sine. So we have sine, and we keep what's inside, sine of 2 theta, and we have that 2 in the denominator still. Now we have to divide by the derivative of our parameter for cosine, which is 2. So we have sine of 2 theta over 4, and then that's plus 1 over 2 theta, because the integral of 1 over 2 in terms of theta is theta, and that's plus c. Okay, but we also know that sine of 2 theta, with our identities, is 2 sine of theta times by cosine of theta over 4. And 2 over 4 is the same as 1 over 2. Now we originally said that sine of theta is equal to x minus 3. So we can substitute that in over here. We get x minus 3 times by cosine of theta over 2 plus theta over 2 plus c. Right, now if we remember this sine of theta being equal to x minus 3, we can actually solve for cosine of theta and for theta. So solving for theta it's much simpler. We just take the arcsine of both sides, so we get the arcsine of x minus 3 is equal to theta. So I can substitute an arcsine of x minus 3 into this term, Now, using sine of theta equal to x minus 3, we can draw a triangle. And we can let this angle here be theta. Now, if sine of theta is equal to x minus 3, that means that our opposite side, the side that is opposite our angle, is going to be x minus 3, and our hypotenuse is going to be 1. So that means that our adjacent side must be the square root of 1 squared, which is just 1, minus x minus 3 squared. Okay, so how does that help us? Well, we're looking for cosine of theta to substitute in over here. Now, cosine of theta is equal to the adjacent side over the hypotenuse. So we can then substitute in this term, which is the square root of 1 minus x minus 3 squared. And I said for theta, we can substitute in arcsine of x minus 3. And we have therefore solved the integral in terms of x. I hope you found this video helpful, and I hope you enjoyed it, and if you did, please don't forget to leave a like and subscribe to my channel.